Every time you see a flowing river, flickering fire or scrolling magic rune, somewhere inside the shader UVs are being offset. Today we'll demystify what that actually means. This video continues our series on VFX fundamentals, so if you've seen the previous one about UV space, you already know the basics. UV coordinates are a normalized 0 to 1 two-dimensional coordinate system where the origin exists in the bottom left corner of the space. So, with that said, think of this 0 to 1 space as 0% to 100% of the image. Every pixel on the model refers to a point on the textures, and those coordinates are called UVs. This is how textures know where to appear on your mesh. So, to understand this concept, let's assume that we have a texture, this glow texture, and we will be sampling it inside our shader or material or whatever. It doesn't matter for now, because we want to understand the basics. And this graph is our UV space. So, if you recall it from the previous video, first of all, there is a UV space, the normalized 2D-dimensional space, and then we are sampling a texture on it. And now we want to offset this texture. And to offset this texture means that we want to move this texture to the right, to the left, to the up, to the down, or in diagonal way of moving. And to offset this texture, as you already probably get, all we need to do is to add or to subtract values on the x or y axis, or on u and v axis, doesn't matter. So what is going on when we're doing it? Let's check. If we add, here is our 0.1 value, and if we add this value, this means that the UV space will shift to the right on 0.1. I will duplicate this layer and I will demonstrate it, not duplicate. And the UV will be shifted to the right, and because of it, if we add 0.1, we will shift it to the right, if we add it on the x-axis. And the texture will move to the left. We will think about it that the texture moved to the left, because we shifted our perception from which we are looking at this texture to 0.1. And so all of the data that was here from 0 to 1, it will be now 0.1, 0.2, and here 1.1. And usually the textures that we are dealing with are tileable one. And that means that they don't have seams and they don't end at the edges here. Create a new layer. They don't end here, but they are tiling, and after they go to the end, they continue itself. And this here will be one more glow. And this means that now we are dealing with this range on x-axis. So we will have a little amount of a neighbor texture. I hope that makes sense. And also we can move it in x-axis, in y-axis, and into axis. And now let's move to the engine to see how it works and how we could implement it. So here in the engine, I have a copy of the text of the shader we used in the previous video. I just duplicated it and I didn't add anything to it. So first things first. First of all, we can use styling and offset checkbox here, turn it on, and if we do it now, if we can, yes, and I applied this shader to the material I used on the preview model. To apply a shader to a material, click here, shader graph, and choose selected shader, and shader graph is from here. I can rename it to something else, and now this will be located in different folder. This will create a folder here, and this way I can keep my shaders organized. So I checked this use styling and offset checker box on, and now I have access to this inbuilt tiling and offset tool in Unity. And let's see, if we add 0.1 on X, our texture move to the left, and we see this small amount of the neighbor texture. So all we need to do to move the texture, it's just add or subtract small, or not small, any amount of data we need. To make it less black boxed, let's don't use this checker box, but let's create a parameter, call it main offset. This is vector2 parameter, and here we have node add, and if we add to our UVs a vector2, we will have exactly this. Now we have this parameter in our material, and if I drag, the texture will be moving. And it's not the end, because we have an inbuilt tool, an inbuilt node that's called styling and offset, and it if we put our parameter in offset, the result will be the same, because it's doing exactly the same. You can see. And the next question that could appear is, what if we want to move our texture during the time, like to move it seamlessly? Now it's a static offset, so we can place a value, but what if we want to move this texture continuously? And this is not something difficult. All we need to do is to multiply our offset value with time. And time is a node in Unity, and that provides a flat time value representing the time in seconds since the game or application started. So to illustrate this, all we need to do is to multiply our offset with multiply our values with time, and time, this is just a node. We have this time, sine time, cosine time, delta time, smooth delta. In 80% of cases, we want to use time output, and that's it. Usually we don't use sine or cosine time, but if you want to know, sine time provides the sine of the same value, cosine provides the cosine of the same value, so it's as simple as that. And now, if I put here 0.1, for example, it will be moving continuously, and 0.1 in this case, this is the speed, because we are multiplying the value with the speed, and now the name isn't correct now, really, because now it's not offset, it's speed. Because, for instance, if we multiply just time, not multiply, if we add our time to our UVs, or use tiling and offset, no, this will be panning like it was one on X and one on Y. But if we want to reduce the speed, or if we want the things to move faster, we need to multiply on a factor. So if we multiply to the values that are from 0 to 1, the speed will be less than it was originally, because if we multiply by, for example, 0.5, the speed will be in 2 times less than it was previously, and if we multiply by 2, we have a faster movement. Yes? So now the name doesn't make sense, it's not offset, it's main speed. And if we multiply this parameter with time, we actually have this already. And if we plug into our offset or into our add, they are working pretty much the same. If we put here 1 and 1, we can see the same result, because the time, this is a flat time value, and it runs every second. And if we want to scroll the texture on the horizontally, we can keep our y-axis to 0. This means that the texture will be still on y-axis, and the movement will be only horizontally. If we want to scroll our texture into the opposite direction, we can use an opposite minus values, and if we want it to move faster, we can multiply to make it move faster, and if we want to move it slower, we can multiply by a small amount and the texture will be moving slowly. And this way we can make our texture panning in all directions we can imagine. And now you can see that I have quite a big amount on Y, so it's panning faster on the vertical axis, and for horizontal axis I have only 0.1, and it's slowly panning on the horizontal axis. So UV offset is just a small mathematical shift, but it's what turns static textures into motion. It's the first step in bringing your effects to life. Next time we'll take a look at UV tiling and how repeating patterns can help us creating textures, rhythm and variation.